Okay, so in my last video, I didn't specify what angle legs were. So these are the little angle legs that I have the students working with to make right triangles and measure and determine if they are right triangles or not. So they just kind of clip these pieces together and form a triangle. And then I have them using the little protractor that it comes with to actually measure out the degrees of the angle. And I do this because I don't want them to just assume that it's 90 degrees because it looks like it's 90 degrees. Like this one looks like it's 90 degrees, but it's actually not. It's like an 80-degree triangle. So these are the angle legs. I use them a lot throughout this unit because I feel like they're really beneficial to actually like have students hands-on visualize what it is I mean when I say a right triangle. And it also helps a lot when we get into the triangle inequality theorem because they can actually see the side lengths and how they don't connect. But anyways, when I'm teaching the converse of the Pythagorean theorem, this is kind of how I delivered the lesson. So when we're talking about the converse of the Pythagorean theorem, what we are looking at is given side lengths, and we're using those given side lengths and plugging them into the Pythagorean theorem to determine if a triangle is a right triangle or not, because we have to remember that Pythagorean theorem only works on right triangles. It's only applicable to right triangles. So our Pythagorean theorem is our a squared plus b squared equals c squared. So a squared plus b squared equals c squared. So the way that these questions are going to be given to students is like this, given side lengths of 3 inches, 4 inches, and 5. Determine if the triangle is right. So essentially this is the way that they're going to be given the question, which is determine if the triangle is a right triangle given the side lengths. So what we're going to do is we are going to take our side lengths and we're going to plug them into Pythagorean theorem. So what we have to remember is that our hypotenuse is our longest side of the triangle. So if we had a triangle that looked like this, our hypotenuse would be the 5-inch side. And then our other two legs would be the 3 inches and the 4 inches. And what we're going to do is we're going to plug into the Pythagorean theorem accordingly. So 3 squared plus 4 squared equals 5 squared. And we're going to evaluate. So 3 squared is 9, 4 squared is 16, and 5 squared is 25. 9 plus 16 is 25. Does 25 equal 25? So yes, 25 does equal 25, so it equals out. So that means that we are dealing with a right triangle because when we plug it into Pythagorean theorem, it equals out. Now, if we were to change this, let's say our hypotenuse is 6 inches now, and let's say that this is 2 inches. So if we were to change these measures, it's going to affect the result that we get. 2 squared is 4. 4 plus 16 is 20. 6 squared is 36. So does 20 equal 36? No. So that means that it is not a right triangle. And that's pretty much the gist of the converse of the Pythagorean theorem. It's a pretty simple lesson. That's why I like to use the Ang-Lee activity to kind of bridge the gap, because I feel like if not, you can't dedicate a lot of time to it. So it's good to have a hands-on activity, and that's pretty much how it goes.